From our learning about autism, this affects person's ability to communicate, learning disabilities, limited social interactions and isolations, and rigidity in behavior. Based on those 4 diagnostic things that we have learned, we would say, why do we need computer-based learnings? First, we know from the autistic centers the activities that they do through notebook activities, repetitions of tests, individual attentions to each student, of course, integration video modeling tests, where computer-based learnings and the integration of virtual environment will be able to combine at the same time text, audio, and video, virtual interactions and reality, and to be able to, for the student to interact with objects. Dynamic simulations of real-world situations, like a situation being in a coffee, a situation of crossing a street, a supermarket, being in the supermarket, entering a bus, going to a bank, preparing going to school, attending a friend party, all aspects of real life. And also be able to provide them with virtual communications through mouse, sensors, keyboard, and haptic devices. Problem statement, of course, whenever we start developing a new product. So the problem statement consists of developing an interactive software that could help improve student motor control, improve students' interactions, improve students' communication skills, and be able also to assist students with object recognitions and applying daily life skills. So we came up with the functional requirements that our product will include: mouse skills, keyboard skill ability, visual tracking ability, interest level, color recognitions, computer component recognitions, typing and text editing skills, and of course the software or the product should have some editing capabilities that being used by the mentor. And of course editing capabilities of sound and script, that means in real time they can change the sound and the scripts. The non-functional requirements are as much important as the functional requirements, especially for this type of applications. And this is, of course, we learned it from the center, the Autism Center in Dubai. That means the GUI, the graphical user interface, should be simple, should include high level of interactivity, color interface, bright, and should include contrasting colors and images, careful selection of sounds and noise, and we should avoid unpredictable events and also avoid negative feedback, that we should also always be able to include encouraging feedback to the student. Our product includes 2 modules. The first module, we called it computer assessment mode, which will have those tasks. The first task is being mouse skills, which help measure the mouse dexterity. This can be done by testing, clicking an object to increase its size, clicking an object to be able to activate an audio sound, clicking and dragging a piece in a 2D puzzle to initiate blinking, for instance, joining the dots. This task helps to measure the mouse dexterity. The second task includes causal and effect relations. And this is done through splashing 3D objects at key press, moving 3D objects using a mouse, and keyboard movements. The objective of this task is to be able to determine the effect of initiating a cause by the student. The third one is visual tracking ability. And this, the student should be able to adjust the speed of the moving object, or for instance, create a path using a mouse. The objective of this task is for the student to be able to track the objects. The third one is interest level. And an example here, a student should be able to move the mouse, to move the box in this case, and count how many balls he would catch. This really tests the student degree of involvement. The third task, or the fifth task, is the screen color concepts. This is about color recognitions and would assess color recognition by selecting certain colors and matching colors. The computer component recognitions is to be able to, the student to be able to name parts of a computer hardware, and these by questions which is displayed on the screen along with several pictures of computer parts. The student has to select the image in response to the questions shown on the screen. Of course, also typing and editing skills. And these will allow the students to learn basic fundamentals at a controlled pace. Module number 2, it consists of daily life skills modules, which teach the student social skills through virtual world using realistic, of course, scenarios in day-to-day life. So it consists of 3 modules, sub-modules, I would say: skill acquisitions, interactions, and collaborations. The skill acquisitions consist of various activities: greeting the teacher, queuing inside the classroom, counting the number of students in a classroom, determining the means of transport to be used to travel to the supermarket, a car or a bus or whatever. So this is where students comes to the classrooms and he will be able to welcome his or be able also to read the shopping list. As you can see here, there are many scenarios that a teacher can select from. This is one of the scenarios. The interaction sub-modules consist of being able to use the key arrows to move an avatar or control the movement of the avatar, which in this case are not automatic. So they are controlled by the student. To be able to navigate the avatar from one to another by using the keyboard, for instance, crossing the street. It allows the user to have more control of their characters. The trigger to be reached will glow, of course, so the user will know at any stage what next to trigger and what they are required to visit. This mode is meant as an advanced mode since it requires by the student more thinking and more navigation power. So this is one of the scenarios of crossing the street. So the student should be able to move the avatar for crossing the streets. The third one is to be able the students to have collaborations with other peers. All the triggers in this case are disabled in this mode. With this collaborative virtual environment, several users' positions at different PC can simultaneously share the same environment and be able to communicate. Every user or each user is embodied by a virtual character or avatar of their choice. They can select their character. The purpose of this is to provide an environment where multiple users can interact with each other. The users can walk around the room and chat with each other in the same environment. This is a simulation of 2 students greeting each other and questioning each other on real time. This needs, of course, a network connections. The purpose of this, as I said, is to provide an environment where multiple users can interact with each other. As I said, the users can walk around the room and chat with the other users present in the environment. Of course, these package include administrative functionalities where the teacher can monitor over time in relation to computer skills the progressions of the student. At any time he can record students' work to view and to be able to analyze students' progress. Back to the technical, these software have been implemented using Java 3D, where it uses graphics, audio, collision detections. Object movement are done by some reusable classes, transform group, transform 3D. Collision detections, wake up on collision entries, Blender, which blend objects such avatars. Panda 3D, this is a free open software. It's called the game engine. And of course, MySQL to keep records in a database. Working with Panda with this package. Here it's the pictures. These are immediately, it's a sequence which are exported to the animation model and which are loaded into the Panda 3 game engine used for the software. This is just a scenario of an avatar working. And this also includes activation of collision capabilities. We are in intention to extend our software. Of course, this involved final projects for our students. And the next one, which is very critical from my own experience, is that projects that are done should not be put on the drawer, but they should be followed on. And the best way to follow on is to extend the projects to other students. And this is through the use of sensors providing touch sensations. That's our next project. And be able to changing faces of the avatars. Thank you very much for your attention. Shukran.
Thank you, Doctor. Our next speaker will be from Kingdom of Bahrain. الأخوات طفل النعيمي وهدى الحامد، وطبعا الورقة بمشاركة أيضا الأستاذة نوال الخاطر ضمن مشروع جلالة الملك حمد لمدارس المستقبل في مملكة البحرين. والورقة تحمل عنوان بيئة التعلم الإلكتروني، ملتقى معلمين المستقبل، بيئة اتصال وتواصل. سيرة مختصرة للأخت هدى الحامد، هي رئيسة فريق تطوير موقع نظام إدارة التعليم الإلكتروني الوطني في مشروع جلالة الملك حمد لمدارس المستقبل بوزارة التربية والتعليم في مملكة البحرين، وعضو مشارك في تأسيس موقع ملتقى معلمي المستقبل بيئة تعلم الإلكتروني مفتوحة المصدر، والذي تم الإعلان عنه كمرحلة تجريبية في فبراير 2009. خريجة شهادة ماجستير في تقنية المعلومات، ومنذ انضمامها لمشروع جلالة الملك حمد في عام 2008 شاركت في عدد من المشاريع المتعلقة بتطوير وتطبيق التعلم الإلكتروني في مدارس البحرين. أما الأستاذة طفلة النعيمي فهي اختصاصية حاسب آلي بمشروع جلالة الملك حمد لمدارس المستقبل بمملكة البحرين، ومؤهلاتها حاليا في برنامج ماجستير إدارة المشاريع في الجامعة الماليزية المفتوحة، كما تحمل شهادة بكالوريوس في المالتي ميديا تكنولوجي من جامعة ليدز في المملكة المتحدة. تفضلوا الأخوات بطرح ورقتكم. تفضلوا.
في البداية أحب أشكر المنظمين لهذا المؤتمر لتاحتهم الفرصة على أساس أن احنا نعرض تجربتنا أو مشروعنا اللي هو